Hey everyone, Chang here and welcome to my channel. Today we're going to focus on proof. Now, I want to say more of a proof tangent. The first time I learned about this, it was in a math class, right? I learned about all these different things in a math class, but a lot of my friends and family who learned these kind of things, actually it was more of a logic class and some of them in more computer science. But I still think it's very important because it actually gets you thinking about the reasoning behind logical statements, true and false, so on and so forth. So today we're going to be focusing on truth tables. Now, these are some of the common symbols, ignoring this of course. This one right here is sort of a V symbol, right? And here's the thing. When we're talking about truth tables and when we're talking about logic, the V itself is basically OR. This one right here is AND. Okay, that's what these two stand for. T, of course, you know, is true. F is false. And this little symbol right here is not. Basically the opposite. So, of course, you have your OR. That's either or is true. And both must be true. Well, you have your true and your false, and not is the opposite. So if that statement, or if that, I guess you could say, whatever, qualifier is true, then the opposite is going to be false, and vice versa. If the qualifier or that statement is false, the not in front of it would actually change it so that it is true. So let's look at how these actually play out. All right, so here we go. You know, truth table. So we have to make tables, of course. Let's look at this. This is the normal or the most general way of presenting PQ, P, and Q, P, or Q statements, right? You will see this in textbooks, in any sort of paper or introduction, which I think is actually really good because it actually highlights very well the difference between and or in relation to true and false and the not symbol. So let's look at this. If P is true, whatever that statement is, based on the problem itself, let's just assume that it is true. Q is also true, then the statement, this combined statement of P and Q is true. If P is true and Q is false, let's change the color and just make sure we can see it. Right? Then the statement itself, P and Q, is actually false. Because guess what? Even though this is true, this is false, therefore that must be false. So you can guess this one. If this is false, if P is false, Q is true, then the overall statement, P and Q, is still false. And so, the last one, if both of these guys are false, as tempting as it might be to say that's true, then no. Actually, if both of them is false, this one's false as well. So, there we have it. For the AND statement, it's actually not in your favor, right? The only time the AND statement is true is if every single aspect of it is true. There cannot be even one that is false. If one of them is false, as we can see, of course, even when the situation when all is false, then the end result is that it is false. Let's look at this one really quickly. We're going to do the same thing with the true and false, and we're going to see the end result where this one is going to be P or Q, right? So we're looking at OR now. Well, if this is true, P is true, Q is true, the final statement you can guess is true. Okay? If P is true and Q is false, the final statement actually is true. Okay? So notice the difference already, right? From here, where it's TF then F, whereas TF, this actually ends up being T, right? Well, let's continue. If this is false and this is true, then you can sort of guess now. The final result is actually still true. And the last one, if it's false, then the last one, well, has to be false. There it is. Okay? Simple as that. So, whereas when you're looking at an AND statement, the only time it's going to be true is if everything is true. Everything else is false, right? If you're looking at an OR statement, all you need is one aspect of that entire combined statement to be true for everything to be true. The only way it can be false is if everything, every single aspect of the different statements is false, then the end result is false, right? So, of course, this is very generalized and very simplistic. Once you guys start seeing these statements, it's not going to just be P and Q. There's going to be combinations of them with parentheses and, of course, the not symbol. So let's talk about the not symbol. If P is true then of course the opposite, not P, has to be false. And you can guess, if P is false, then the not symbol is going to have to be true. Now, this seems arbitrary, so let's actually look at problems, look at statements, and see how this kind of reasoning actually plays out. Alright, so your first basic encounter with problems are probably something along the lines of this, where they would give you two statements, but then at this point you actually have to evaluate yourself whether it's true or false, and then answer the rest of the question. So let's just look at this one really quickly. So first and foremost, we have P, and the statement itself for P is that 2 is an even number. True or false? Hopefully at this point you guys are comfortable and know that this statement itself is true. The second one, Q, 57 is a prime, right? Or a prime number. Well, if this is the case and you're not entirely sure, then yes, you actually have to check. If you are familiar with divisibility rule, which I do have a video if you want to check it out, right? You can tell this is actually not a prime number. This is actually divisible by 3, right? So check out how you can immediately tell just by looking at a number if it's divisible by 3. So this statement itself is actually false. Cool. So that's what we always have to do in these situations where they give you a statement itself and then you just evaluate whether the statement is true or false. Then you can start answering these ones because these are just basically combinations of the statement. So in this case, we have P, the V symbol, and then Q, right? And this can get a little confusing because you don't want it to represent some sort of variable. This is actually, the OR symbol. So P or Q. Well, that means we are talking about true or false, right? In this case, well, in this case, because it's an OR, it doesn't matter that Q is false and P is true. All we need is at least one of them to be true. If that's the case, then this whole statement is true, and it happens to be it. So this entire statement is true. Now let's look at this one though. This is true, right? P is true, and false. Well, I mean, if we write it out like this, yeah, it clearly does not make sense. But remember, for the AND statements, right, you have to ensure that every single aspect of it must be true for the entirety, the combination itself to be true. If not, if even a single one is false, then boom, it's going to be false. So in this case, it's true and false, which makes no sense. Of course, this whole statement is going to be false. Now, the last one is slightly interesting. First and foremost, we know that P is true. We know that Q is false. But this is a not Q. Not Q means we basically get the opposite. Since the original statement itself is false, then that means not Q must be true. So we're talking about T or T. So in this case, T or T, well, I mean, it's a bonus, it's a plus, you have extra, but at least one of them is true. So this entire combination, this entire statement is true. Just like that. Alright, so let's look at something that's even more math related. So let's look at these statements right here. So first one, we have P. The statement itself, 15 plus 17 equals 32. So true or false? Hopefully you guys got it right away. This statement is actually true. Right? The second one takes a little more finagling, trying to understand exactly what it's talking about. You have the absolute value of x is less than 0, where x is an element of the real number. So hopefully you guys are at least somewhat comfortable in reading something like this. Basically, it's saying that for any number x, because it's part of the real number group, right? Any number x, the absolute value of it must be less than 0. That's false. All right? Hopefully you guys realize that, because guess what? Absolute value of any number is usually positive, or if it happens to be the absolute value of 0, then it's just going to be 0 itself. So this statement is blatantly false. Well, now that we've gotten these two statements, we know that the P is true and Q is false. Now we start looking at combinations of them. So the first one is actually slightly different. We have a not P. Remember the symbol? What is this, right? Or Q. So in this case, what it's saying is not P. So originally, if P is true, not P is actually false. It's going to be false or, and Q is false. So notice that it is false or false. Since all aspects, and we're talking about or right here, all aspect is false, then that means this final statement is false. Okay, well, let's look at this one. Well, the second one, we have P and Q. We know that P is true and we have an and Q is false. Well, luckily at this point, we should be somewhat familiar. Since one of the component is false in an and statement, then this must be false as well, right? And the last one for this one, we have P or T. Scary stuff, right? This is interesting because when I first saw this, I actually got super confused. Like, well, there's no T statement. Well, because it's not a T statement. It just means true. So it's going to P or T. So we know that it's going to be true or true. So in this case, this entire statement is true. So just be careful of that, because guess what? When we get accustomed to looking at longer statements, right? These are all the like super easy generalized one, but then of course you're gonna have a really crazy complex one with different knots and different parentheses to group them together. And then they start sticking these things in, where they start putting true and false values in there just to screw with you. You gotta be careful, right? So something like this, I just threw it in there so you guys can see it, and when you encounter it, it won't just completely throw you off guard. Now this last one right here is just for fun. When I first saw it, it's just the weirdest written statement I've ever seen. I actually didn't know what to make of it, and it took me a while, even with like several classmen explaining to me such a blatantly obvious answer, that I just couldn't wrap my head around it. Because I mean, from kindergarten all the way until like, I don't know, at that point, you know, college for me, this statement was never written in any way like this, right? Because if we were to look at 13 plus 12, when we solve it, we immediately know what it equals to exactly, which is 25. Okay, it's equal to 25. So when I first looked at this statement, my gut instinct immediately told me that this is gonna be false. Why? Why would you ever write less than or equal to 25, right? We know that 13 plus 12 is just 25. But actually the statement is true. And like I said, it took me a while. The interesting thing is, because of this, this represents less than or equal. And with an or statement, either one of them can be true for the entire statement to be true. Less than is clearly not it, right? At this point, we should be comfortable knowing that 13 plus 12 is not less than 25. So this part is false. But because it's an or statement and we know that it actually is equal, this part is true. So since it's an or statement and one component is true, this entire statement is true. Now, should you write it like this? For fun, I guess. Just throw people off. But I mean, I personally, that's probably a lot easier, and it makes so much more sense. All right, so there you have it. That's the basic introduction of truth table. Now, that is very general, and once again, very basic, very simple. When you encounter these in your study in math, logic, computer science whatsoever, of course it's not going to be that simple. There's a lot of different ways to play around with logic, right? They would give you a combination of a statement and say it's true, and then start giving you components, and you start solving it like a logic problem or a puzzle, where you start deriving, because this one is true, therefore this one must be false, and so on and so forth, right? And that would be combinations of and, ors, and nots, and all that other stuff. Now, here's the key though, right? Because there's so many different ways to write problems, and there's so many ways to make problems more complicated, it just doesn't really make sense to try to just cram it all in one video. I wanted to show you the basics, but I want you guys to leave with this. After understanding the basics, just knowing the difference between and, ors, and nots, right? Just be very careful. The things that throw people off is just what statement is combined with what, with the parentheses and the not outside the parentheses, talking about the whole thing, or just individual components, right? Take it one step at a time. Take it slowly and just start writing value, true, false, all the way through, and just keeping the parentheses and the nots and so on and so forth. And eventually you'll just be able to find the answer, right? You'll be able to solve it, and you won't get confused about it. Be organized is the key for this, right? Other than that, have fun. This is usually a puzzle logic, and if you love those kind of things, you'll definitely enjoy this kind of study a little more, definitely. If you have free time, Google some problems just to check them out. Well, thank you for watching this video. Please like, comment, and subscribe. I will see you in the next one.